Okay. I hope now we will have smooth connection. Let us resume. So here, main goal is that we should make some prediction, whatever data we have not seen previously. And for this purpose, we are using a training data to build the model and then applying on the test data. So here, the main aim is to increase the accuracy for the predictions. Okay, for example, in case of emails, so I want to be definite that the current email or new email which I have received from some another source, etc., I should be able to accurately, that is, my algorithm should be able to accurately guess whether that email is spam or not. Okay, and for this purpose we use supervised and unsupervised many machine learning algorithms, and right now we are focusing on the supervised learning. So here, supervised learning often requires human effort to build a training set, but afterwards automates and often speeds up other laborious or infeasible tasks. So here, main thing is that in case of supervised, here I cannot let my data train get automatically. Okay, so here, in order to increase the accuracy, we need to change the parameters, we need to increase or decrease the variables, change the number of features, etc. It means whenever we are building the model, many tasks or many ways we change in order to get the accurate result. So here the main purpose is that we wanted to increase the accuracy. So accuracy can be increased by changing the model. Previously, I was performing simple addition. If that is not giving me the expected output, then I may go for some multiplication. I may go for some division or some other operation, just like mean, variance, etc. It means that there are many operations which will lead me to take the correct output. Just like in the reach, etc., we have seen the concept of alpha parameter, okay, or which is also called as a coefficient parameter. So if consider we wanted to have to get the maximum accuracy, we may go for changing parameter values as well. So it means that initially human efforts are required to change the model or to change or to build the model on the training set or training data. And hence, if consider my model is built properly with more accuracy, then it means that that will automatically decrease my further work when dealing with the test data. Okay, and in case of supervised, there are two types of the algorithms are there, or two types of the problems are there. First one is classification and another one is regression. So what is mean by a classification? Classification, it means that whatever data set is there, to that data set, I wanted to give some class level. Okay, for example, we have seen the implementation of classifying the iris flower classification. So it means that I'm having the physical data or physical measurements of my flower, and I wanted to categorize that flower into some of the class label, some of the classes. And that's why it means that I wanted to give any name to that data. So it is a classification. So which is a choice from the predefined list of possibilities. So it is not mandatory that always I predict the accurate result or accurate class, etc. So it depends. So classification is sometimes separated into binary classification and multi-class classification. So binary classification, it means that there are only two types of the cases, classes, that is yes or no, or just like in case of emails, if email is spam or not. So it means there are only two classes. I wanted to divide the given emails into two categories, spam or not spam. So it means only two classes, just like if I'm answering the question whether this is type yes or no. Okay, so similarly this comes under classification, whereas multi-class classification, this comes under just like iris flower classification we have seen, where we are having more than two classes, or we have seen the example of three classes. Not only yes, no, I will have multiple types of the classes. I cannot answer to the question yes or no. Here there is no way. We can have the intermediate answer, etc. Okay, or many of the classes for this. Whereas when it comes to the regression, so regression, it means that first, what is meant by a regression? Regression, it means that where I can expect a continuous output. Okay, continuous output, it means that when we are talking about the classification, in the classification I'm having exact answer 1 2 3 4, or a class 1 class 2 class 3, or binary classification either in class 1 or class 2, or yes or no, etc. It means I'm having only fixed answer here, that is, which is not always, it means it will belong to the either of the classes. Just like it means I cannot have the continuous values class 1 class 1.1 etc. No, these are the not continuous values or continuous output. But regression, this works with the numbers or outputs which may have the continuous number or continuous values. So for regression tasks, our goal is to predict a continuous number, so which doesn't belong to fixed values of classes. For example, I'm having 4 classes. I cannot have output more than 4, etc. Class 1, class 2, class 3, and class 4. That is a fixed answer I will get. But when it comes to the regression, I cannot get what output I will get. I can have output from 1 to 100 or they based, which we are calculating. For example, I'm calculating some annual income. So I cannot, based on education, etc. If I wanted to calculate the income, then I may go for any wide range of values, etc. Okay, for given set of data. Okay, so for regression tasks, the goal is to predict a continuous number or a floating point number in programming terms or real number in mathematical terms. Okay, here example is given, that is predicting a number, predicting a person's annual income from their education, their age, where they live is an example of a regression task. Okay, so it means here I'm calculating the income, but which doesn't have which may have a continuous value. When predicting income, the predicted value is an amount. Okay, can be any number in the given range. Okay, another example of regression task is predicting the yield of farm given attributes such as previous yield, weather, number of employees working on the farm, etc. So this yield can again be an ordinary number. Okay, clear with the difference between classification and regression? Okay, take a minute. Okay, in the next point as well, I'm having the definitions. So let us see those definitions. So here, I wanted to differentiate between classification and regression tasks. So it means which task comes under classification and which comes under regression. So here the main difference is that whether I'm having the continuity in the output or not. Okay, if there is a continuity in the output, then the problem is regarding the regression problem, just like we have seen the example of predicting the annual income. But if consider I wanted to recognize the language of website, it means that here for website I may having multiple languages, so there is a no, it means I cannot guess a range, etc. Okay, so website is in one language or is in another, so there is no continuity between the languages. So here I can decide, that is, if these are the keywords, this language belong to, that is website language belong to this language, or language of this website is this. It means that I can categorize there. So okay, if there is no language between English and French, I cannot have the continuity here. So this is the first point, that is classification and regression algorithms. So total there are 6 algorithms: naive Bayes, k-nearest neighbors, logistic regression, support vector machines, decision trees, and random forest. Okay, so these are the most widely used algorithms. So let us see one by one. So here it is not mandatory that, so under classification regression, these 6 algorithms are there. It means that here some classifiers can also act as a regression algorithms, and some regression algorithms can also work as a classifiers. Okay, so classifiers, it means that those who classify into the categories. So here the difference between two is given. So first let us see what is meant by a classification. So classification, it means that it is the process that tags and categorizes any kind of data so that it can better be understood, it can be better understood and analyzed. And regression, it means that estimation of continuous dependent variables or response from list of input variables or features. So here I'm expecting a continuous dependent variable or continuous value. Okay. So here sometimes there is an ambiguous line between classification algorithms and regression algorithms. So many algorithms can be used for both classification and regression. So classification is just regression model with threshold applied. When number is higher than the threshold, it is classified as true, while lower classified as false. Okay, please take a minute to read this slide, and then we will move to the next point. Okay, done with this? Clear with this? Any problem? Unable to understand what is meant by classification and what is meant by regression? If no problem, then we will move to the next point. May I? Okay, these are the total 6 algorithms which we are going to learn. So now let us start with the naive Bayes first algorithm. So here, naive Bayes, this classifiers as a family of classifiers. It means naive Bayes is used for the classification, and which is very similar to the linear models. So okay, but the difference is that they tend to even faster in training. They train very fastly. Okay, the reason that naive Bayes models are so efficient is that they learn parameters by looking at each feature individually and collect simple per class statistics from each feature. Okay, so here the main thing here is that it learn it means that they are trying to train the model, learn parameters by looking at each feature individually and collect simple per class statistics from each feature. Okay, so it means that here we are learning feature by feature in terms of naive Bayes. And whereas in case of linear models, all the 3 variations we know that in terms of a single line, that is y equal to x0 multiplied by w0 plus w1 multiplied by x1, etc. In that way, we are having the formula for the linear model. So where we are taking all the features into the considerations. But when it comes to the naive Bayes, it will perform the statistics with respect to the each feature. Okay, it means that each feature is studied for the characteristics and to learn the model. Okay, so when it comes to the implementation, these are implemented in scikit-learn library, and there are 3 classifiers are there: Gaussian, naive Bayes, Bernoulli's, and multinomial. Okay, so these 3 are there. So let us see what the 3s are. It means 3 classifiers are. So Gaussian naive Bayes can be applied to any continuous data, while Bernoulli's NB assumes binary data and multinomial NB assumes count data. That is, each feature represented an integer count of something. That is like often a word appears in the sentence, etc. For example, I'm having some real values or I'm having some integer values. But when it comes to the Bernoulli's, we are talking about in terms of 0 and 1 data. So Bernoulli's and multinomial are mostly used in text data classification, and Bernoulli classifiers count how many every feature in each class is not 0. Okay, so we wanted to understand whether each feature is not 0. That is how many classes are there and whether it is 0 or not. Okay, for example, let us see this by using an example. So this is an example. So here I'm having an X array. Okay, it is a 4x4 2-dimensional array. So within that, this is my first row, second row, third row, and fourth row. So here we know that when it comes to the matrix, each column represents a single feature and each row represents a single data item. Okay, रो म्हणजे माझा डेटा आयटम आणि वर्टिकल म्हणजे प्रत्येक फीचर. Okay, right now I'm having data of 4 items and 0101 says that whether that feature is available or not. Okay, so here I'm having X and I wanted to have the output, that is array equal to single dimensional array 0101. So here when it comes to the Bernoulli's, we wanted to extract the features and we wanted to perform the classification. Classification, it means that I wanted to classify, that is it is a binary classifier. Okay, we wanted to study this X, and based on that we wanted to decide how Y should be get calculated. Okay, so for this purpose here we have 4 data points with 4 binary features each. There are two classes, 0 and 1. Okay. For class 0, the first and third data points. Okay. First and third data points. Okay. First and third data points. The first feature is 0 2 times. Okay. Here in terms of matrix, it is taking this as a first, second, third, and fourth. Okay, so it is not taking 0 1 2 3. So it is taking 1 2 3 and 4. So here class 0 I wanted to say, so first and third, the first feature is 0 2 times. Okay, here I'm having 0 2 times, and non-zero 2 times. The second feature is 0 1 time and non-zero 1 time, and so on. The same counts are calculated for data points in the second class. Counting the non-zero entries per class in the essence looks like, that is, we wanted to calculate how many non-zero values are there. So here, this will go for calculating by using the unique. So NP unique, this will check whether this is having a unique from the Y, that is 0101. Then here we iterate over each class. Then count some of the entries of 1 per feature. So what we will do? So this is one feature. The first column is one feature. Second column is another feature. Third and fourth are also another features. So I wanted to calculate the unique Y. That is, we wanted to go for each label into the class. So here we will calculate, that is, we wanted to count some entries. So 0, 1, 0, 1, I'm having 2. In the second feature, 1, 3 zeros are there. So it means 1. Then for the third, oh, sorry, it means changed the way of explanation. See, nobody's interacting me. Here, I'm talking about data points and we should talk about features. Features, this is a vertical thing, and data points, these are the horizontal or rows. So whenever I'm saying first and third data points, this first and third data points, the first feature is 0. Yes, done. But I wanted to go for counting 0 entries per class. So we are talking about counting the entries of features. Okay, entries of 1 per feature. So when it comes to the per feature, I'm performing the vertical addition. Vertical addition, 0, 2 ones are there, so 2. Then second feature, 1 and 3 zeros, 1. Third feature, 0 and 2 ones are there, so 2. And the final feature, I'm having 0 ones and 3 times 1. So I will get 3. Okay, so here counting is done. So feature, I will print the format and I will check whether feature counts, that is, I'm having 0 equal to array 0 1 and 0 2 and 1 array 2 comma 2 comma 2 0 2 1. Okay, check this. Okay, done. So now let us go for the next. So here, this is an example for the name base, that is in case of Bernoulli's classification. So here we applied for the binary classification, and based on that we perform, that is input whether 0 or 1 is there. Based on that we decided which classification or in which class it will be, that is data point lies. Okay, so now there are some strength and weaknesses of each of the algorithms are there, or each of the weights, or each of the naive Bayes classifiers are there. So here, whenever we are talking about multinomial and Bernoulli's naive Bayes, these are having a single parameter alpha, which controls model complexity. It means alpha variable can change its value, and based on that we will decide whether that is how much complex our model can be. So the way alpha works is that the algorithm adds the data alpha many at virtual data points and have positive values for all the features. Okay, so this is called as a result smoothing for the of the statistics. A large alpha, it means that we are having more smoothing and results in complex models. And the algorithm's performance is relatively robust to the setting alpha. That is, in a single go, we cannot get the value of alpha. So meaning that alpha value is not critical for good performance. However, tuning usually improves the accuracy. Okay, so it means that alpha can have any value. So based on that, we can decide how much accuracy we will get. So it means having a fixed alpha value or critical value of alpha, that is when we accurately calculate alpha, how I will get the output exactly similar to the desired output with increasing accuracy. Okay, so that's why alpha values are changed. But when it comes to the Gaussian naive Bayes, so it is most widely used for the high dimensional data. That is, whereas other two variants are used for the sphere count data such as text, etc. Okay, so multinomial NB usually performs better than binary NB, that is our Bernoulli's, particularly on data sets with a relatively large number of non-zero features. Okay, so large documents are there. Whenever we are having other than 0 and 1 values, then we will go for the multinomial. So here, and when it comes to naive Bayes, so the naive Bayes models spare many of the strengths and weaknesses of linear models. So they are very fast to train and to predict, and the training procedure is easy to understand. The models work very well with high dimensional sparse data and are relatively robust to the parameters. So naive Bayes are models are great baseline models and often used for the very large data set, whether training even a linear model might take too long. Okay, so whenever we are having the large number of the features or large number of data, there naive Bayes algorithms are preferred. So okay, before going to the decision tree, please take a look at this features. Read this slide for a minute and next slide as well, and then we'll go for the decision trees. Okay, all of you add your roll numbers into the chat window for the attendance, and you might need to attend the lecture offline. So be in a seminar hall. So write your roll number in the chat window and you can leave the meet.